Right, I'd like to get started, please. So today is the last lecture forever. Some of you might never see math again. Okay, so before I start out, do you guys have questions from Friday? Josh, you're the only one that does homework, so Josh, questions. 15 and 17. Okay, let me get to the right page here. So give me a couple of minutes, okay? All right, so can I get started, please? So number 15, okay, on page 826. And the problem goes I equals 1 to n. And what are you supposed to do? Rewrite the sum as a rational function. Use Sn to complete the table and then find the limit. Okay, this is a great precursor for what we need today. Sorry, this is an I here. I squared 1 over n. So part A, rewrite the sum as a rational function. Okay, so part A, rewrite it as a rational. Josh, do you know what a rational function is? No what? No, that's not true. What's a rational function? That's not true either. That's not true either. Okay, without a sigma or an I or anything like that, what's a rational function? Sorry? Like what kind of fraction? Remember, we are in pre-calc. Sorry? Guys don't remember poly over poly? Polynomial over a polynomial? Guys don't remember that? Okay, polynomial over a polynomial, that's a rational function. So what they're asking you to do is make that like a rational function. In other words, they want a polynomial on the top and a polynomial on the bottom. Okay, this guy is going to be a polynomial in I and n. Okay, n is actually a constant. I is going to be the variable here. You guys really want Amy? I'm really getting pissed now. Seriously. That side of the room just doesn't shut up. You guys have a pretty big test coming up on Thursday, okay? And there are no makeups for you guys, you know that. You either get it or you don't. Okay, so this guy then becomes 1 minus I squared over n squared. 1 over n. You guys follow my handwriting there? It's kind of... You guys got that? So then this becomes I equals 1 to n squared minus I squared over, hello, n cubed. Okay, so that's part A. Part B, use Sn to complete the table. Need I do anything in there? Josh, need I do this? Do you know what I'm doing, Josh? Sorry? What happened to it? I times everything downstairs by n. Okay, so I am skipping steps here. I'm skipping like algebra 0 steps, okay? Isn't it n squared times n? Okay. Part B is okay, making a table. Josh, are you awake? Part A, there are 3 parts to the problem. Guys, you got to be with me, man. I have a lot of stuff to do today. I don't have any time. Today is it. Okay, you guys got to be with me. That's part A. Part B is the table. Okay, and then part C, they're asking you to take a limit as then goes to infinity. So in other words, part C, this is what they want you to do. Limit n goes to infinity of sigma n squared minus I squared over n cubed. Okay? Yeah? The answer is different? Like what is the answer? Part A or part C? Part A? What the hell's going on with this guy? Are we looking at the right page here? Number 15, page 826? Yeah. Josh? For part A? Rewrite the sum as a rational function Sn. Okay. Okay. Okay, so this really, Ilim, is there any way you can not do that stuff, Ilim? Ilim, is there any way you can not make that racket there at the back? Thank you. Okay, this goes back to, this is a great problem for what you're going to need in a few minutes, okay? So what I want you to do is go to page 615. Do they repeat it in here? Do they repeat that on page 820? Okay. The reason why I want you to go to 615 is because I want to rub it into you that we've been there, done that. Page 615, chapter 8, been there, done that. The thing is repeated over again, as Nate is saying, on page 820. Okay, so you've seen it on page 615, and it's back again on page 820. Okay, so we need to use that. So let me go get this back. Okay, so actually what I'm going to do here is go back and rewrite this differently, okay? So I'm going to erase this stuff. I'm going to write this as sigma I equals 1 to n of 1 over n minus sigma I squared over n cubed I equals 1 to n. Is everybody with me on that? What's going on with this dude? Can you let me be in control here, okay? Yeah, stupid Bill Gates again. Okay, is Josh, you with me so far? Can you tell me what? Okay, what's your problem, dude? Can you tell me what this is equal to? Lizzie? Isn't it just 1? Isn't this a constant? Right? So if you take a look at number 1 on the box on page 820. You with me on that? Item number 1. So in this case, C is 1 over n. So you got 1 over n times n gives you 1. Which is what Liz is saying. Okay? And the next one, what is sigma I squared equal to? What's sigma I squared equal to? N times n. No, it's n times n plus 1. 2n plus 1 over 6. Okay? And we need to do some algebra on this. Okay, we need to do some algebra on this. So we're going to have 1 minus n squared plus n times 2n plus 1 all over 6n cubed. So everybody with me so far? And do more algebra on this, and it becomes 6n cubed minus 2n cubed minus n squared minus 2n squared minus n all over 6n cubed. Everybody follow this algebra here? You guys got it? Okay. A little bit more algebra. Get 4n cubed minus 3n squared minus n all over 6n cubed. Is that the answer? Minus 1 at the end. Oh, huh?
That's what minus it's supposed to be 3n squared minus 1.
Yeah. But downstairs it's 6n squared.
Oh, okay.
Come on. And you guys are smoking now, man. God, yeah. Jeez. Don't smoke, okay, like me. I'm allowed to smoke because I've been there, done that. You guys are not allowed to smoke. Okay? So, what they've done is they've cancelled out one of the n's in there. You guys with me on that? So that becomes 4n squared minus 3n minus 1 over 6n squared. This is a rational function, right? Remember I told you poly over poly? You have a polynomial at the top, you have a polynomial at the bottom. Part A. Part C, they want you to take limit of this as n goes to infinity of 4n squared minus 3n minus 1 over 6n squared. Now on Friday I gave you a bunch of rules that you should have known from back in chapter 2. Remember that? Are you guys reviewing for the final? Okay. All right, make sure you are, okay? Emma, you should know the answer to this. The answer to this question. What is it? Which is 2 over 3. Everybody know why? Eric, you look confused and or lost. Tired after a weekend? Well, weekends are parties. Priscilla, you look like you're zonked. Huh? 4 projects. Surbir is out for the count. Udara has always been out of the count. And some people are more interested in yearbook than in math. Your choices. You guys know that you are making the choices. When you don't do well, it's the choices you have made. Okay? Just like my calc students. My calc students on Thursday, 39 out of 66 kids are doing a makeup. They are seniors. This is the last chance. They don't make it, they get rescinded. Because of the choices they made. Because of the poor choices they made. Okay? I can't emphasize that enough. Okay, everybody get 2 over 3, Josh. Can Emma show everybody? I'll pause here. Emma, you do the math. The goal right now is to, so this was a 5, okay? Is to see what happens to the area as this number goes to infinity. That's our goal, okay? And we're going to do the same kind of tricks that I just did in problem number 15. Very similar tricks that we're going to do, okay? So the first thing you want to do is understand this formula here. Okay? And I've rewritten it like this. So I'm going to pause here, make sure that you guys understand this, and then I can move on. Everybody understand how you get here? Yes? Okay? Because all you need to do is take this guy and put it in place of x. That gives you this. Is everybody okay? Yes, everybody here? Okay. What are we going to do with this? Let's move on, okay? So everybody get the transition from here to there. What did I do there? Sorry? I pull the 205 on the outside because it's a constant. Okay, it's a constant, so I can pull it out of the sigma sign. And then I just squared 2 over 5, which gives me 4 over 25. Okay? You guys with me on that? Okay. So now look at this part here, okay? Look at this part here. Which is kind of like this part here. Okay? Which goes back to those formulas that Nate just pointed out, and I told you that we've been there, done that in chapter 8. So we need formulas like what on page 820, okay, on page 820. Okay, so here are, these are some of the formulas that I'm talking about, okay, this one here, and you obviously know what this one is, okay, or I think it's a C, they use a C in here. Okay. So in other words, those 5 or 6 formulas, frankly, I expect you to remember 1, 2, 3 at least, maybe not 4, but 1, 2, 3 for sure. You got to know. Okay, and I have tested you on this. Okay, in chapter 8, so we've been there. So we need those kind of formulas, and this is the reason why we need those formulas, because like I'm saying, what we're going to do is take this formula and do this to it. Okay, this is what you're going to do to it. Okay, which is exactly what Josh had me do on number 15. Okay. So let's proceed with this. So the first thing to do is like what that problem had suggested, which was to write things as a rational function. So what is sigma I equal to? Sigma I is 6. What is this first one equal to? What? Lizzie? Sorry? 6n. And then what is the other one equal to? Go back to page 820. Look it up. Look it up.
N plus 1 plus 2 minus 2n plus 1.
All over?
All over 6.
All over 6. Can you guys read this, or can you actually write it yourselves? Are you guys okay on that? I'll rewrite this, okay? Hopefully I don't get into a crunch again. Something's not sounding right to me. Something doesn't look very good to me. The 6n doesn't look good to me. Because as n goes to infinity, that's going to blow up. No, okay. Okay, well, we're okay. We're okay. I think I need more space to write on. It's going towards infinity, just like in problem 15 was. Okay, just like what was in problem 15. Okay, so I need to write this as a rational function first. Okay, so someone help me write this as a rational function. Can I reduce the denominators here? Is that okay? And then I get 25 times 3 times 6n. Can someone do that math for me, please? 25 times 3 times 6. Come on, get your calculators out, dude. Oh, why are you guys being so freaking lazy today? What's up? 450n. Yes? Minus, can I FOIL the upstairs? So the upstairs is going to be n squared plus n times 2n plus 1. Zara, can you come and sit here, please? And the common denominator is, sorry? 75, thank you. I'm not very happy with this somehow. I don't know why. Things are not looking very good to me. Sorry? Things are not looking very good to me because I would have expected a 1 over n somewhere. Oh! Boom! Why is there a 5? Why is there this 5? What should that be? Okay, how did we get that 5 in the beginning? How did we get that 5 in the beginning? From Friday. How many did we have on Friday? Yes, it was 5. But what do we want? Where did this guy go? He even changed the background on me. Okay, Bill Gates, stop it. Ha! Okay, I am screwed basically here. Got to start all over again. That's okay. That's okay. I'm doing the work. You guys are sleeping, so it's all okay. I don't mind doing it. Do you guys mind sleeping? It's okay for me to work? Yes? Start over again? Okay, let's do it. So let me go to the next page because that's better. Is it better? No, this page is good. Okay, I'm going to work on this problem here, okay? So we need to fix this. I had a feeling it wasn't looking good. Okay, so the first thing I need to do is change this. Change this to infinity, and this guy would be infinity as well, except it won't be infinity. Actually, that's not the right way to do it. This is the right way to do it. I'll make that an n, make this an n, make that an n. So then this guy would be an n, this guy would be an n, this guy would be n squared. Okay? So now what I want is I want limit as n goes to infinity of this stuff here. So that's 2 over n sigma I equals 1 to n 6 minus 4 over n squared I squared. Okay? Guys got that? Okay, I want you to use the formulas on page 820 to go simplify this and write this as a rational function. Just like I did in number 15 a few minutes ago. Okay, so I'm going to pause here, get you guys to do this. Okay, has everybody gotten this far? Now I'll tell you that you don't need to FOIL this stuff here. You don't need to, and I'll tell you why in a minute. Okay, I'll tell you why in a minute. Did you get this far? Did you get a 12 by itself? Do you see where the 12 is coming from? Need I explain that? Hello, anybody home? Everybody see where I'm getting the 12 from? No, Priscilla? All you are doing is timesing this by this. You are really sick, Priscilla. This is not something you'd miss. Okay? And the reason why you don't need to fold the other stuff is I'm going to be invoking the rules that Emma just told us. Okay? Emma just told us the rules that the degree of the numerator is the same as the degree of the denominator. Then the limit is just the ratio of the coefficients. You guys got me? Okay? Now, does this guy depend on n? Does this guy depend on n? Does 12 depend on n? No. So then the answer out of there is going to be 12. The answer from there is going to be a 12. Okay? This other guy, what's the degree of the numerator? What's the degree of the numerator? Remember, the degree is the highest power you're going to get. 3, what do you think is its coefficient? 8? Is everybody there? No? Got it? What's the coefficient of the downstairs? Hello? 3. What does this equal? (28/3). So remember on Friday we did how many rectangles? 5. You got an answer there? What was the answer on Friday? What was the answer on Friday, people? I'll be with you in a few minutes. Okay, let me get the answer from Friday. Did you guys take notes on Friday? Yeah. Can you look that up and see what your answer was on Friday? Oh my God, what's up with you, man? Wow, what you guys doing? You guys are killing me. Yeah, dead week, not like you are dead. No. You got finals next week. Yeah, so you're going to, crank it up a notch. It's like, what do you think OKC does? Do you think they're going to sleep after the game too? No, they're going to take it up a notch. What was the answer on Friday? 8 and what? 8.18? 8.48? Something? What is this equal to? 9.333. So if you had taken, instead of 5 rectangles, if you had taken 10 rectangles, you're going to get closer to this number. Okay? And so the most exact answer, the precise answer, no approximation at all, is exactly that. I'll be with you in a minute. So the area that we were trying to find on Friday, you guys remember that picture? Do I need to bring that up? It was this area we were trying to find. We did that first with 5 rectangles. Today we did it with an infinite number of rectangles. We got an exact answer, 28/3. No questions about it. Question?
When you got from, it says 4/3n squared times 1, shouldn't that be 2/3n squared?
Yeah, but then there's another 2 outside.
Oh, I see.
Okay? All right? And then there's another 2 here. So there are 3 2's there. 2 times 2 times 2. Okay? That's how we got 8/3. You with me? Okay? All right, I'm done with this. Today's homework 33 through 43 is all problems like this, where you're supposed to write it as a rational number and then take the limits. Okay? All right.